Dr. Chuck the Science Schmuck.
Synchronize. Impressive range. So, I've been going through my junk. And I have a lot of junk because I accumulate things. As you may have seen, depending on whether or not I published that video first, it's actually sitting right there. I had found my old multi-vibrator instrument and reworked and rebuilt that into a much more functional version, a much more professional looking version. That's not the only instrument that I found in my pile of junk. So this is going to be another one of those. Pause for dramatic effect. Then reach over and grab the, this doesn't even have a word for what it is. That's music right there. That's a musical instrument. Somewhat. Okay, this thing takes some explaining because it works on a principle that is very... What is that? What is that? Why is that? How is that? Where is this? Never mind. It works on a principle that's very functionally different from what you would normally expect an instrument to work on. Looking at what I constructed, it appears to be a piece of aluminum through which various sized random half-drilled holes have been made. There's a significant amount of corrosion, and it looks like there's a sticker here once. But the most noticeable thing you may see is these decaying electromagnets. Those are big coils of wire with iron cores designed so that when you charge it you can pick up metal. This system places motors next to these to generate a musical frequency. Now, what do I mean by that? So a DC motor is with a brushed DC motor. I'm not going to go into brushless because they run purely on voodoo. There's two magnets. One north is abbreviated as N. Should be R for north. North and a south magnet. In the center is a coil which spins. As that spins, it has two probes on it that power it. So the electricity goes through that electromagnetic coil and gives it a polarity which causes it to rotate. Mean anything to you? Why does it rotate? It rotates because the electromagnetic field will temporarily be rendered south. North is N. It doesn't make sense that north is N. It should be R. The electromagnetic field through these coils renders this temporarily as south and north, causing it to... So it's switching between that so that it will attract north to south, south to north. Right? But as it spins, there's a mechanism in here that, because of the way it's hooked up, switches the polarity. That's called the brush. It's a little copper brush that when it switches, it grabs a different portion and switches it so that those become the opposites. And then suddenly it switches again because it's repelled from up here and attracted down there. That's not the best explanation of how a motor works, but what it means to say is essentially in a DC motor, which this device uses, there is a spinning electromagnetic coil which, as it rotates, is generating variable frequencies, both because of its physical motion and because it's changing polarity rapidly. It produces a magnetic field which, as it spins, can be detected by one of these electromagnetic coils and converted into sound. Now that occurs by an amplifier, as you would in a guitar. A guitar uses a similar process to these, except instead of detecting a spinning motor, it detects a vibrating metallic string in front of it. String. So the idea of this device, which this device did work, although this is new, was that when power is connected to the motor spins, the coil picks up the electromagnetic sound of the motor spinning. Controlling the voltage to the motor, or current to the motor, I guess, can drop the frequency by slowing the motor, or you can touch the end to give the motor more resistance and slow down the sound. The machine is not in working order right now, but I do remember what it sounds like. It does not sound like something you would want to hear, but what have I ever built that does? Don't answer that. I'm going to repair this thing. So looking at it, what do I have? All the solder has decayed in a lot of places where it probably shouldn't. Instead of using electrical tape, it uses blue painter's tape. So the biggest problems here is this coil is disconnected. There is no audio jack currently on it. Like that wire is supposed to be soldered to there. I am missing a motor, which I found elsewhere. It fell off. This motor is really rusty, but I think it still works. It's still connected, but it is not in the location it should be, so it needs to be affixed into the proper area around these coils. So the motors need to be reattached. It looks like I actually put great effort into building a transistor control circuit. So these are power transistors, TIP 122. I even got them all the same. Wow. I was fancy when I made this. I don't know why it's got batteries on it exactly, but we'll figure that out later. Transistors right now. So the transistors should be controlled by what? They should all have a control lead at some point of their being. I think that's these. Okay, so the idea then is that connecting these will activate the transistors, which then allow the motors to move, but there's no actual control circuit. So what needs to be done to refurbish this? I'm not going to write it down. You don't need to see this. I'm already recording it. I'll just look. I do not actually look at these videos. I can't stand to hear the sound of my own voice. Probably neither can you. So I'll try to keep the talking to a minimum. I won't try to keep the talking to a minimum. I really like talking. Step 1 is to restore all physical systems of the motors and motor connections to full. Step 1A, 2A, is to figure out what the power supply is. So that's step 3. 1A is to build another board to put switches and potentiometer control on these, as well as, I think these were meant for like a higher level control system, so I can install a port maybe? I don't think I have the tools for that. That's like step 7. Stage 1, gotta repair the hardware. Well, I've gone through the circuit a little bit, and I found several key issues. First of all, motors are never marked properly in terms of their voltage. Second, it looks like the system was designed to use 3 batteries, which is 4.5 volts. I think I was supposed to jam like a piece of metal in there to get the voltage correct, but who needs batteries? Why not? There it goes. When you have wires that connect to things. Of course, that does present a problem in that this wire presents 12 volts. What in the world is trying to crawl through my walls? And do I care? This is actually a 12 volt line. 12 volts is probably too much for the motors and risks them burning up. So I went through my circuits to try to find something that would counteract it, and I found a tiny voltage regulator circuit that I don't really know why I had, but based on the fact that it was connected to like a 10 watt resistor, I think I was trying to use that to drop a 30 volt power supply to like 5 volts, which is a bad idea. It's possible, yes, but it will heat up a lot. I glued that to a block of wood, and I also installed this big switch. It's got some nice aluminum holding it in so that it can switch on and off. That's the resistor. The actual circuit was built into some white milk jug, which I can't remember the last time I drank milk in a white milk jug, so that's old. But yeah, it's an adjustable voltage regulator. I had to switch up the resistor a little bit, which is located right behind that thing, which I think is part of the door on my old house. Don't mind that the screws are different colors. I found 2 different colored screws that were roughly the same size. but that resistor gives it about 3.7 volts because it's an adjustable LM. It's so faded I can barely read it. LM317T. So that reduces the voltage from 12 to a consistent amount. The multivibrator has the same thing, even though the 555 can actually take multiple different voltages in terms of its input. I have temporarily connected it to the circuit, which I have actually determined that these transistors are NPN, meaning that they're... Do I need to explain how a transistor works? A transistor is like a switch, where it has an input and an output, and then a center lead, which is not in the center in the TIP form, but it's basically a control lead, which is, in this case, since it's NPN, when you apply positive current to that wire, it allows electricity to flow through the transistor like a switch. Those are connected to the motors so that when, right now I haven't attached any switches, so they're just blank wires. If I touch one of these to positive, the motor will turn. I've additionally installed a jack, which connects to my Kona amp here. So, let me plug that in. I might put an indicator light on this because it's at a voltage that an indicator light would work. Turn on the amp. So, here in this case versus the multivibrator, if you recall the multivibrator, put a 555 or 555 output straight into that. So that's straight voltage right into the amp. This circuit doesn't do the same thing. This is not electrically connected to that. All that amp is sensing is the electromagnets that it's wired into in parallel here. It's just an amp connected to big coils of wire that are next to motors, which results in it being somewhat quieter. So, Pensy, I'm going to transition you to be in front of it. I don't know if you can still hear me. But I'm going to link this control wire to the positive, just tap it, and it should generate an audio output over there. That's a different, smaller motor. So, just to make it 100% clear, if I down the volume on that entirely, that's what the motor sounds like on its own. That's what it sounds like when I actually turn up the amp. So let me find the... That's one of the quieter motors. If I tap it... So the circuit works now, and nothing in it is overheated, as far as I can tell. That's a little warm. I'm sure that's fine. So that's operational. The problem being that it looks like this right now. So the next stage is to actually put a control system on these exposed wires so that I have switches and can turn them on and off. And to build this into a structure where I can actually use it. So that's going to take a while, but that's much more easy to do than trying to figure out how in the world this actually works.
I glued it to a piece of wood. In actuality, I got the wood cheap. It was warped. It's pressure-treated lumber. Nice size, like that's real fancy wood. Ooh, sawdust everywhere, 70% off. It is not entirely glued. It is in fact screwed. There's several screws holding many things down. This section is glued? Some of it's glued, not all of it. But going through the various pieces that have been aligned and positioned, so the motors are of course on that aluminum rail, which is screwed down to the front, so that it has the motor apertures. Those are the motors, and these are where the coils are held in, audio jack. These are the control transistors, which are right behind it. So those are the actual portion that turns on and off the motors. The switches are on this board, literally a board. I use wood to make my boards. I drill my own holes with my own... Well, I don't use my own fingers because I have weak fingers, so I have to use a drill. But they're stuck in. I use some snap action switches I found in a box. The neat thing about those is they're nail size, so I could nail them in there and then glue the nails in, because I did not have screws or bolts of the appropriate size. The power control board is, of course, over here. The actual circuitry is just sort of attached to that piece of plastic, but it's pretty well held in, so I don't think it's going anywhere. I also put in an LED to indicate when it turns on, which just crosses across the power. So when the device is actually connected, and you can see, you didn't hear that, but it sounded like somebody just tried to punch my door real hard. Well, you can't get in, and I can't get out. Until I'm done anyway. Connecting the 12 volts to, again, this is a 5 volt or 3 volt, 3 point, it ended up being 3.7 because I had to get a random resistor out of my random resistor box. The switch is held on by aluminum, so push that to the no setting. Oh, the on setting. So you can see, green LED. I like the green LEDs with the white, I like LEDs with white casings. See? Because LEDs produce multi-frequency, blah, blah, blah. An LED produces a specific frequency, so the light is not colorful when it's off, and then it turns a color when it's on, so you can definitely be sure that it's on. When that is connected, all power is running through the system. It is now possible to control everything through the switches. So that's what it operates in acoustic mode, more or less, not actually, because it actually is electric right now. I don't know what that wire is for, but it clearly doesn't connect to anything, so I guess it's not necessary. But as mentioned previously, for me several weeks ago, for you probably almost immediately, the device actually senses through an amp. So, audio jack goes nicely into the audio hole, and then I can turn on the test amp. Let me turn down the volume. So, yes, the motors do actually make noise. Again, it's pointing, it looks like that, but it's pointing at me because you're actually hearing, you probably just heard me poking your eardrum. It operates through this, so you hear what I hear, basically, theoretically. So yeah, the actual amp is picking up the electromagnetic fields detected by the surplus electromagnets put right next to the motor. So this does not connect to this circuit in any way. It's just connected to a bunch of coils that are detecting the magnetic fields of the motors as they spin. Which means that, you know, I had originally thought, well, I'll put a potentiometer and have a knob so that I can control the tone. The thing is, motors don't like when you have resistors connected to them, so it either turns off or is barely noticeable. What I can do is by touching the actual shaft of the motor, I can slow the motor slightly, which reduces its frequency. It's a little loud. Let me turn down the volume a little. Since they're all in parallel, I can use them all at once. This one I think sounds the best. It's the smallest. That's actually a solar motor, so it's designed to run on like half a volt, but it tolerates 3 just fine. The question is, at this point, what is the definition of a musical instrument? The answer is this probably doesn't apply because that isn't music, that's the amplified sound of a drill. It is very similar to the sound a drill actually makes, except it is done with the guise of a device that's essentially an instrument, so I can... Somebody's hitting the wall behind me. I don't think they like this. Regardless of that, it does seem that it functions in its initial manually controlled version. That does ask the question then, if you're being observant, why didn't you just put these through the switches? Why did you build that whole transistor board? And what are those blue things in the middle of it? The answer to that, if I actually manage to get it to work, will show up after I build. Well, it does seem that what I was intending on planning was both planned, executed, and marginally functional, in that the setup was successful. So, those blue things, what are those blue things exactly? Those blue things are parallel with the switches in such a way that they're basically the base of the transistors. So that if an electrical current, positive, because they're NPN transistors, if an electrical current was applied to that blue node, it would trigger the transistor as if a human had hit a switch. The point of that was for the purpose of automation, the idea that this system could be set up with a computer linkage so that it could play itself automatically. And that's what I've done. That's a little tiny Arduino. I think that's how it's pronounced. Arduino. This is a Uno. I found it in a bag in a box, and it had apparently been in my basement for years. Interestingly, since there's no wood or cardboard in it, it does not go moldy like everything else I own. Interestingly, rubber goes moldy too. You wouldn't think it does, but it definitely does. So what I have done is connected this Arduino to those three transistors. I did not know how to use an Arduino until this morning, when I started learning very quickly. And essentially, it makes no sense if you try to do this like a motor control. Or I have no idea how to operate a switch still. So I'm a beginner with 3 hours of experience. But as a tribute to how easy the Arduino is to use, with 3 hours of experience, I have been able to make a system that should be able to control this using basically what it does is it says, it does all the setup because it's the weird way Arduino does things is it sets up the pins. You have to name the pin to say activate this pin as an output and whatever. Then it will produce an analog output at whatever pin I tell it to, which in this case is 9, 10, and 11, at a certain power level that is between 0 and 255, which is the controller's speed and basically the frequency that the motor will output. And then it can delay that. It can say do that for 1/4 of a second, 10 seconds, however long you want it to. That means that that code, if it were put incorrectly, you could trigger the thing to accompany a human instrumentation system when it's active. In theory, still have to figure out a switch for it. Part of the issue, though, is that the power is not quite the same because this thing already has a regulator, and an Arduino can't really take 3.7 volts. It becomes unstable below 5. However, an Arduino does have a voltage regulator in it, which means that I solved the problem of powering it by creating this. What is this? It's a plug, a female plug connected to 2 male plugs. Explaining to you what you can see with your own eyes. So I take my 12-volt line and I put it in there. Now I have 2 12-volt outputs. One of these can go to the Arduino, and the Arduino's regulator will handle 12 volts, that's the maximum voltage one should take, and convert it into positive whatever. The other will power the system. Since it's all connected to the same power source, the positive from the Arduino will still be entering the same circuit because you can't take a separate circuit and then feed it into a totally isolated circuit through a transistor and expect that to actually work. So if I connect one of these to my circuit here and I turn it on, the LED light has indicated. I have connected that back up to the amp. Let me modulate the volume a little. Okay, interesting feature. When the thing is plugged into the Arduino, I do not know the reason for this, but it is a discovery I just made. There probably is a circuit design thing that you could answer if you came along to it. Every switch turns on the same motor. I don't know why that is, so there's no manual override. Now, I've pre-programmed the Arduino, and since I have not yet figured out how to connect a switch to turn on the program, it should just start playing automatically when I connect it. So I'm actually unsure what that really high sound is, and why it's doing that. I think it's one of the motors, but I don't know why a motor would be doing that. So I just unplugged one of them. I just unplugged two of them. Okay, so now it's only connected to one motor. And I plug it back in. So there's clearly circuit errors inbuilt into the system that I do not fully comprehend or understand that do weird things, but the computer runs the system. The thing runs. Everything in this circuit works exactly about as well as I expected to it, because my expectations were naturally kept relatively low. So this is now not only a manually controllable musical instrument powered by the rotation of motors, and not only one that can also be switched to be powered by motor control circuitry through a microcontroller, but it sounds terrible, which is exactly what I was expecting. So I consider this to be a smashing success, and that should be everything that needs to be done with this project. So I've actually done pretty well today. So, end.